That's the chain of compositions, basically. So the most outer one, careful, what's the most outer function here?
Sine.
The fifth. Next to the fifth, right? The fifth power function. So when we take the derivative here, the first thing we're going to do is lower the power by 1. So the 5 comes down in front. 5 sine to the 4th, and the inside stays the same. Cos of 3x. These problems are very visual, I think. I don't think it's much of a logical process, much as just seeing what's going on with all these compositions. Equals, sorry, not equals, times what?
dx of cos 3x.
Careful.
Cos, sine, just the sine. Should be cos.
Of sine
Negative sine.
cos 3x.
Really?
Let me just explain. Cos 3x. What function is inside the fifth power right now? The sine function. So you haven't differentiated anything to do with sine yet. All you do is bring the 5 down and replace the 5 with a 4. You did a power rule. So what is awaiting to be differentiated, or taking the derivative of, is the sine cos 3x. Okay? Sine cos 3x is put inside the fifth power. You differentiated the fifth power aspect. Now you've got the rest of this trig function left over. So now you take the derivative of sine cos 3x. Okay? Now I'll make the, I'll write the whole thing. Cos 3x. What is the derivative? What's the most outer function here now? The sine. Now sine's the most outer. What's the derivative of sine? Cos. So we should have cos, right? Times the derivative of the inner cos 3x function, right? d dx cos 3x. Okay? Equals. Write the whole thing again.
Negative sine?
That's right. At any stage that you can see how this would end up, the last part will end up, you don't need to write out every little single composition. You know what I'm saying? Every little next derivative. If you know in your mind already the derivative of cos 3x, which hopefully you will in another couple of days without thinking too much about it, then you would just write that immediately. Right? Once you get to a stage that you know exactly what the rest of it is, you should write that. Anyway, so 3x here. All this is the same, except for that little tail. So the derivative of cos 3x under negative sine, you were correct. So negative sine of what? 3x times what? Times the derivative of 3x, which is 3. So if that's abundantly clear to a person, then they would, instead of writing dx of 3x here, right, you would just write a 3 right there. Once you know how it's going to end up, just finish it off. But nevertheless, we'll take it through the entire chain. So now we have it. 5 sine 4 cos x cos 3x. The derivative of 3x is 3. Negative sine 3x times 3. Okay, so there. The chain rule is complete. Now it's just a matter of cleanup. So we have negative 3 and 5. So negative 15 is up front.
Well, can't we just put the 3 in front of the sign?
Is the 3 in front of the sign at this stage?
Or,
Yeah, certainly. Yeah. I just put it there just so
Okay.
as you look through this, right, you see what's you know that
Yeah.
this piece is this piece, and I know that this piece is this piece, and I know that this piece is that last piece. That was yeah, certainly. So that's actually all you need to do, right? Just make that negative 15, and the rest is the same.
where's?
That's the derivative. Okay? So not so easy the first time you see it. Any questions so far? there's a 5 here and a negative 3 there. So they're just multiplying those together.
So you can just take it away from the sign?
Yeah, because it's all multiplication.
Okay.
Yeah, this is not being subtracted or anything, right? This is just a negative on this thing. So negative 3 times that 5 will be there. Okay, two derivatives. Find second derivatives. Number 48. Find double prime. Y is x times cos x squared. So this has two basic things going on with it. It has a composition. The x squared is being put inside the cos function. And then it has a multiplication by x, right? So what is the outermost thing which is happening in this function? What's the outermost thing? Not composition necessarily, but the outermost thing, outermost operation. That's right. So the first thing you're going to do is product rule. That's right. Always look at that most outer thing. So dy dx is going to be, if we call this one first and this one second, but it happens to be that when we differentiate the second, in this product rule, we're going to do a chain rule, right? It's all happening together. So dy dx is going to be first times the derivative of the second. I'll just write it, d dx, since I don't know what it is initially. So cos of x squared, let's write notation, plus second, the cos of x squared, times the derivative of the first. Well, you know the derivative of the first automatically. The derivative of x is 1. So there it is, right? You can write the 1 there if you want, but it doesn't really do much. Okay with that? Chain, that make good sense? Yeah. Right. So now we're just left with this little piece here. So equals, so now if we do a chain rule on the cos x squared, we'll have x times, so I need to take the derivative of the outer function. The derivative of cos is negative sine. So we have negative sine. The x squared stays inside, the inner function stays inside. I have to differentiate the inner function and multiply it onto that. Since you know that already, the derivative of x squared is 2x. I will skip the notation. I'll just write 2x on the tail of this. Okay? There's that, plus the lingering cos of x squared over here. Does that make sense?
No.
What'd you say?
No.
Now we'll just clean it up a little bit. We will combine the two. Are we talking about the 2x and the x? We will write this as negative 2x squared sine of x squared plus the cos of x squared. That's what they were looking for. So just because there's a composition in the problem does not mean composition is the first thing you deal with. You don't do chain rule first necessarily, right? Always try to look for the most outer thing which is happening within the function. Yeah?
Where you got two verses.